Good afternoon, students. Today we will see the next topic of unit number 5 for the subject of microprocessor, that is features and block diagram of a DMA controller 8257 and operating modes of 8257. Now here for this 8257 operating modes, let us say that the DMA controller 8257 in microprocessor based system, data transfer can be controlled by either software or that the hardware. To transfer data, microprocessor has to do the following tasks. The first task is that fetch the instruction, decode the instruction, execution of the instructions. So microprocessor needs some amount of time to complete these tasks, but this data transfer is not suitable for large data transfers such as data transfer from the magnetic disk or optical disk to memory. In this situation, hardware controlled data transfer technique is required. Direct memory access or DMA mode of data transfer is the fastest amongst all the modes of data transfer. In this mode, the device may transfer data directly to the memory or from the memory without any interference from the CPU. So Intel's 8257 is a 4-channel DMA controller designed to be interfaced with their family of microprocessor. Each channel can be independently programmable to transfer up to 64 KB of data by DMA. Here 64 KB of data by DMA means that the memory size of that the 8086 microprocessor is in and around 64 KB. So each channel can independently perform read transfer, write transfer and verify the transfer. Now in maximum mode of the microprocessor, RQ/GT pin is used as a bus request input. On receiving the HLDA signal in minimum mode or RQ/GT signal in maximum mode from the CPU, the requesting device gets the access of the bus and it completes the required number of DMA cycles for the data transfer and then hands over to the back towards to the central processing unit. During any given bus cycle, one of the system components connected to the system but is given control of the bus. This component is said to be the master, which is component connected to the system, and the component it is communicating with is said to be that the slave. So it is divided in the two categories: system components connected to the system but is given to the controller bus is said as a master and slave respectively. The CPU with its bus control logic is normally the master, but other specially designed components can gain control of the bus by sending a bus request to the CPU. After the current bus cycle is completed, the CPU will return a bus grant signal and the component sending request will become the master. So taking control of the bus for a bus cycle is called as that the cycle stealing. The DMA data transfer is initiated only after receiving HLDA signal from the CPU. The 8257 on behalf of the devices requests the central processing unit for bus access using local bus request input HOLD in minimum mode. This is the internal architecture of 8257, which is having 7 to 8 blocks are to be here. The data bus buffer, which is a bidirectional from D0 to D7. Read write logic block is where IOR, IOWR are the active low signals along with clock, reset and some pins are to be there. The third block is that contrast logic and mode set register with the pins ready HRQ, HLDA, MEMR, MEMW. These are some active low pins are to be there. These three blocks are interfaced through the internal bus through the to the channels starting from 0, 1, 2, 3 with 16-bit address and the count registers. Some peripheral registers are also connected through the channel 0, channel 1, channel 2, channel 3. Here it is the peripheral devices are to be there. In the channel 0 16-bit address and count registers, DRQ0, DRQ1, DRQ2, DRQ3 are connected to channel 0, 1, 2, 3 respectively, whereas DAC 0 bar, DAC 1 bar, DAC 3 bar and DAC 2 bar, 3 bar are connected respectively to these channels 0, 1, 2, 3. Now, how the DMA operations are performed here. So there is some sequence for the performance of that the DMA controller. Initially, when any device has to send data between the device and the memory, the device has to send DMA request in terms of that the DRQ to the DMA controller. The DMA controller sends the hold request HRQ to the central processing unit and waits for the CPU to assert the HLDA. Then the microprocessor tri-states all the data bus, address bus and control bus. The tri-states, it is for that the three states of that the data bus, address bus and control bus. The CPU leaves the control over the bus and acknowledges the hold request through HLDA signal. After that, the CPU is in hold state and DMA controller has to manage the operation over buses between the CPU, memory and input-output devices. The chip support 4 DMA channels, that is 4 peripheral devices can independently request for DMA data transfer through these channels at a time. These are the 4 channels. The DMA controller has 8-bit internal data buffer, a read/write unit, a control unit, a priority resolving unit along with a set of registers. The 8257 performs the DMA operation over 4 independent DMA channels. Each of 4 channels of 8257 has a pair of two 16-bit registers as a DMA address register and terminal count register. There are 2 common registers for all the channels, namely mode set registers and status registers. So total count of that the registers is 10. The CPU selects one of these 10 registers using the address lines A0 to A3, and these address lines A0 to A3 functions is represented in this table. If all the address lines A0, A1, A2, A3 are 00, then channel 0 DMA address register is to be selected. Then if A0 address line is 1, then channel 0 count register is to be verified. Then channel 1 DMA address register is set when the address line is 1 and A1 is 1 and remaining all are zeros. And the channel 1 count register is initialized only if and if A0 and A1 address lines are 1 1. Like that way we can initialize the channel 2 DMA address register, channel 2 count registers, channel 3 DMA address register and channel 3 count registers. There are 2 mode set registers, mode set register which is used for the write only and the status register is used for the read only when the address line A3 is to be 1. There is a 14-bit count which is represented from the B0 to B13, B0 to B13 and B14 and B15 are used for the, if they are 00 to verify transfer, if they are 01 write transfer, 10 for read transfer, and if both are in 11 position, then it is a illegal situation. The mode set register is used for programming the 8257 as per the requirements of the system. The function of the mode set register is to enable the channels individually of the DMA and also set to various modes. This is a signal description of 8257. Mostly it is a 40 in signal description of the 8257. The ground is connected to us to that the pin number 20, and the 31 is pin number 31 is assigned to us to that the VCC. So IOR bar, IOWR bar, MEMR bar, MEMW bar, then DAC2, DAC3, DAC0, DAC1. All these are that the active low signals. We will see one by one. DRQ0, DRQ3 as mentioned here in the pin number of 16 from which starts from 1980, 17 and 16 is a 4 individual channel DMA input request input used by the peripheral devices for requesting the DMA services. The DRQ0 has the highest priority, whereas the DRQ3 has the lowest one priority. DAC0, DAC3 is these are some pins which are mentioned in the 24, 25, 14, 15 pins. So these are the active low pins are there. The DMA acknowledge output lines which inform the requesting peripheral that request has been honored and the bus is relinquished by the CPU. These lines may be act as a strobe lines for the requesting devices. Now the pin numbers D0 to D7 are the bidirectional data lines used to interface the system bus with the internal data bus of 8257. These lines carry command words of 8257 as well as status word from 8257 in slave mode, and that is under the control of CPU. The data over these lines may be transferred in both the directions as they are in a bidirectional. The 8257 is the bus master mode that is not under CPU control. It uses D0 D7 lines to send higher byte of the generated address to the latch. This address is further latched using ADSTB signal. The address is transferred over D0 to D7 during the first clock cycle of the DMA cycle. During the rest of the period, data is available on the data bus. IOR is again an active low bidirectional tri-state input line that acts as an input in the slave mode. In slave mode, this input signal is used by the CPU to read internal registers of 8257. IOW, this is an active low bidirectional tri-state line that acts as an input slave mode to load the contents of the data bus to the 8-bit mode register or upper lower byte of a 16-bit DMA address register or terminal count register. In the master mode, it is a control output that loads the data to a peripheral during DMA memory read cycle. The pin is clock. Pin is used for clock frequency which is required to derive basic system timings for the internal operation of 8257. Reset is an active high asynchronous input disables all the DMA channels by clearing the mode register and tri-states all the control lines. A0 to A3, these are the 4 least significant address lines. In slave mode, they act as input which selects one of the registers to be read or written. In the master's mode, they are the 4 least significant memory address input lines generated by 8257. CS, this is an active low chip select line that enables the read-write operation from 8257 in slave mode. In the master's mode, it is automatically disabled to prevent the chip from getting selected by the CPU. A4 to A7, this is the higher nibble of the lower byte address generated by 8257 during the master mode. Ready? This is an active high asynchronous input used to stretch memory read and write cycles of 8257 by inserting wait states. This is used while interfacing slower peripherals. HRQ. The hold request output requests the access of the system bus